Okay, so today I want to talk about circular measure. And you remember a circular measure mostly had to do with radians. It's almost always going to be in radians. And what we're talking about is arc length and area of a sector. And one of the problems I've pulled is probably, it's either from last year or from the year before. And what happened was it really threw some kids. Now, what's going to happen is when we're doing this kind of thing, what we want to do is we want to make sure that we are looking for right triangles. And the problem with this one, as you can see, is that there's not very many right triangles. There's no right triangles. And so what you've got to do is you've got to go through here and you've got to fill in the information. So it says the diagram shows a symmetrical metal plate. That's this whole figure right here. And the plate is made by removing two identical pieces from a circular disc. So number one, this is a circle. This is supposed to be a circle. However, two pieces have been removed. The two pieces are both semicircles. So we know that the original was a circle and that we've taken out two semicircles, and P and Q and P and RS, they're the diameters. So what happens is, let me see if I can do this. If I go from here to here, and here to here, these represent diameters. And they tell us that the diameters are going to be a certain length. What is it? Looks like it's supposed to be, it says the diameters are 4. So that means this is 4. And this is 4. So one of the things I'll tell you is in a problem like this is start by adding stuff to the picture. Sometimes what happens is they give you a picture and literally everything that they have in the words is actually in the picture. And sometimes not everything is. So we've got this round plate. We've taken away two semicircles. So again, this is a semicircle. That would make this a center point. And this a center point. And see, now I can determine this radius is 2. And this radius is 2. And it says that the radius of the circle with the center C is 4 centimeters. Now, the thing is, at this point, it doesn't seem really clear where it is that I can put that 4. They've already told me that P, Q, and RS are equal to 4. So we've already labeled that. So now let's take a look, and it says show that angles PCS. PCS is 2 pi or 2/3 pi. So what I'm going to do now is I'm going to create this angle. So it goes from P to C, and then to S. Whoops. What happened there? Let's try to undo that. All right, now, what we've done is we've gone from the center to a side of the circle. So now we know that I can tell you that this is a length of, oops, hang on, let's go back again. We can label that a 4. So let's go back to drawing. And because they told me that the radius of the circle C is 4, I can now add this. And see, they want to know what the angle is for PCS. Or they actually want to tell us, they want us to tell them how it's 2/3 pi. Anyone got any ideas about how we can do that?
We could try to create a right angled triangle.
Where will we put it?
You could
See,
maybe.
this edge over here is rounded, right?
Yeah.
Now, what if we did this? Is that going to be a right-hand triangle?
Yeah.
Yeah. And again, what if I go over here and do this? Well, now it's an equilateral triangle, but certainly that's, or not equilateral. Well, no, it is an equilateral, isn't it? How do I know it's equilateral?
The radius is 4.
That's 4. This radius is 4. This is 4. It's an equilateral triangle, right?
Yeah.
All right. So that's awesome. All right. Now, what can I do with that information? They want me to show that this right here is 2/3 pi. Mitchell, what do you think?
We're trying to show that's 2/3 pi.
They are.
Right. So, well, when you have the line, is that equal to 1 pi? Is that right? Right? Because it's 180 degrees.
This whole line here from Q to S?
Yes, that line. Like, that would be equal to just pi, right?
That whole thing would be equal to pi, because that's 180 degrees. I get that.
Okay. Yeah, so then, like, you can show, like, that's 1/3 pi, like, from, the line PC to line QC.
Right. So take a look at the situation. I really don't have much information over here. I've got tons of information over here. If this is 4, what's this right here?
2 and 2.
Right? Okay. Now, if I have a right triangle, can I find an angle if I know 2 sides?
Yes.
I can, can't I? Now, don't you agree that these two have to be exactly the same?
Yes, they would.
So if I found these two, or this one, and then doubled it, well, then I'd be able to figure out this other one, don't you think?
Yes.
All right, so let's see about that. What would I use? This is the angle I want to know. What sides do I know?
If you're going from angle C, it would be the opposite over adjacent.
And which one does that?
Oh, wait. No, would that be the hypotenuse?
Oh, good question. So what is side 2? We're agreeing that's opposite, right? From this angle, right? What's side 4?
Sorry, did I cut out? It said something about
I didn't hear you.
Yeah, sorry. So you have the opposite and you have the hypotenuse.
Exactly, because it's across in the right angle, right?
Yes.
So the sine of an angle is equal to the opposite over hypotenuse, which in this case is going to be what?
2/4.
2/4. And then what do I do to figure out that angle then? I'm going to do the inverse, right?
Yeah.
When I do the inverse, where's this angle sign go?
On the other side.
And then what goes on the inside?
-1, 2/4.
Well,
Or
and we
1/2.
can just do what's 2/4 reduced to?
1/2.
Exactly. So if I do that, now I know the angle. Now, do me a favor, take your calculator and tell me what's the inverse sine of 1/2.
It is 1/6 pi.
So we know that our angle is 1/6 pi, or pi over 6, which I don't know why I just wrote pi over 2. Pi over 6.
Mhm.
Now, what would 2 of those be?
1/3 pi together.
So, how do we finish this question? How do we answer A? What's happened is we've got all the stuff, but now with this show things mean we've actually got to use words to explain what we know. This math is good, but so now what do we say?
I would say the straight line of QS
Well,
is
let's use circle words. What is that line that goes from S to Q through the center in a circle?
the diameter. Would
So
that
if
be
we
the-
say the diameter, SQ,
SQ, yeah.
all right? And then
Um,
if we say, so then what angle are we referring to here?
180.
PCQ?
yeah. Yes.
Angle PCQ, that's telling them that this is this, right?
Is 1/3 pi.
Is equal to, and I'm saying pi over 3, but it's the same thing, right?
Yes.
So, or you can put therefore,
Mm-hmm.
PCS must be pi minus pi over 3, or 2/3 pi. Does that make sense?
Yes.
That is us telling them exactly what we were trying to prove. We've found this angle, like you said. Hey, if this two angles right here equal 1/3, well, we know that this has to be 1 pi, and so that's, again, you could do. There's no one way to do it, but this is what you want to express. You want to let them know that, hey, I know what's going on here. Does that make sense? Any questions about that? Giovanni, you get that?
Wait, you got pi from the straight line, right?
Yeah, because keep in mind, what happens is that straight line is a diameter, right?
Mm-hmm.
So what's this angle right here got to be?
It'll be 2/3 pi, right?
Well, no, if this is the diameter, or this is a straight line, this is going to be 180, right?
Yeah.
And so if this is pi over 3 together, that must be 2/3 pi. Does that make sense?
Yeah, that makes sense.
All right, so now what do they want us to do for part B?
They want us to find the perimeter.
All right, so the perimeter of what? The perimeter of the plate. Okay? So, what can we do about that?
We can find the PS.
We can find the arc length. Is that what you're saying?
Yeah, the arc length of PS.
All right, so let's say PS, and we're going to say it's an arc, right?
Yeah.
Plus the arc length what?
Of QR.
QR. And what's more, we really aren't going to find both of them. Don't they have to be identical?
Yeah.
Okay, so PS is going to be the same as QR, right?
Yeah.
All right, but that is two things, right?
Mm-hmm.
Then what else?
We have to find the arc length of PQ.
PQ. Well, wait a minute now. Find the exact perimeter of the plate. Okay, so now what happens is it's this shape here, right?
Yeah.
2 times 2 times PQ. Tell me about this right here. What is this shape?
It's supposed to be a circle, right?
What kind of circle? Half of one, isn't it?
Yeah.
So how do I find the perimeter of half the circle?
Don't you... There's a formula for this, right?
Sure. Well, what's the formula for a circumference of a circle?
Isn't it 1/2 pi r squared? Or I'm missing...
Pi r squared, let's go up here. So the area of a circle is equal to pi r squared, okay?
Yeah.
The circumference of a circle is equal to pi 2r, or pi doubled, pi r doubled. Or sometimes people say pi times diameter, because the radius is half of a diameter, right?
Mm-hmm.
Now, if I want half of a circle, what am I going to do?
You'll divide it by 2.
So this is going to be 1/2 pi times 2 times r. Yeah?
Yeah.
Well, what's 1/2 times 2?
2? Wait, no. 1.
Right. And what's our r? What's the radius of this circle? Now, mind you, this is a smaller one up here. What's the radius of this circle?
It's 4.
The diameter is 4. What's the radius?
2?
So, no, because remember, take a look. Here's the circle I'm talking about. Where's the center? Right?
Yeah.
Do you see how that is going to be a 2? Yeah?
Well, no, because it says like the radius of the center of the circle is century. C is 4 centimeters.
Yeah, but
would
that's circle C. That's this
Oh.
circle. That's this circle. Do you see what I'm talking about?
Yeah.
This circle here, they told us that this diameter was 4. Remember when they said PQ is equal to 4?
Mm-hmm.
PQ is equal to 4? Well, if the diameter is equal to 4, what's the radius got to be?
It would be 2, right?
Exactly. Right?
Yeah.
So, if these cancel out, then really all I'm doing is 2 times pi, right?
Yeah.
Now, there's another one down here, exactly the same size, right?
Mm-hmm.
So how much is that going to be?
It'll be the same thing, right? 2 pi.
Exactly. So now, all we've got to do is add 4 pi to it. Does that make sense? Here's our
Yeah, I think...
here's our perimeter. Our perimeter. Let me get rid of this thing here. I don't know if I can get rid of it or not. Our perimeter is kind of maybe harder to see because I've drawn in these lines, but our perimeter is this. This is kind of hard to do because I'm doing it upside down here. That's the perimeter. Are you with me on that?
Yeah, I get that.
All right, so now you see PS, that's an arc length, right?
Mm-hmm.
So QR, that's an arc length, right?
Mm-hmm.
And then we need this thing right here and this thing right here, which we've already figured out. Now that's 4 pi. So now all we're going to do now is find out those arc lengths. What are those arc lengths?
That would be.
How do you find arc length?
You do r and r times theta, or r times the angle.
Exactly. So the arc length, S, is equal to the angle times the radius, right? So
Yeah.
what's our angle?
2/3 pi.
Which they made sure we knew about. What's our radius?
2, right?
Now again, now remember, we're looking at this circle now. Do you see that this is the radius?
Wait, so there's 2. Okay, I think what's tripping up is like you're telling me there's 2 circles.
There are 2 circles.
Yeah, that's what's come.
Okay.
Kind
There's one circle that we took half of.
of. Mm-hmm.
Okay.
Yeah.
That's the center of those 2 circles. This circle C, even though we don't have the whole circle, that has got a radius of 4, which they told us.
Oh, okay.
And I will tell you that the reason this is such a good problem is because it really does encompass a lot of the problems that people run into when they get on the test. Because what will happen in these kind of problems, there's more than one circle usually, a lot of times, and you don't see the whole circle. And so sometimes it's hard to tell what's going on. But anyway, do you see this right here? Do you see how this is an arc length? So what's 2/3 times 4?
8/3 pi.
So
8 out of 3
yeah,
pi.
right. So it's going to be 8 pi over 3. This is going to be 8 pi over 3. And this is going to be 4 pi, right?
Yeah.
Add them all together. Tell me what you get. Just do the same thing. Use the pi signs. It should give you the answer in pi. Or if you want, add 16/3 plus 4. What's 16/3 plus 4?
I got 28/3 pi.
Yep. All right, you good with that?
Yeah, I think after this video's done, I'm gonna do this problem again because to look at that circle, try to understand the 2 circles.
I know. Well, and I will tell you that, like I said, part of the reason I chose this one is because it is definitely one of the tougher ones I've seen. What happened was they've changed the syllabus like 2 or 3 years ago, and it's been kind of hard really because of all the COVID stuff. But what happened was they changed some of the things that we're going to be covering, but they're also taking this stance of trying to do a little bit more problem solving. And so I think this is an attempt at trying to create a problem that really requires some kind of some different problem solving skills than problems I've seen before. This is a tough question. And the thing is, I've never seen one like it before. So when the kids in my class got to the exam and they saw this, I mean, most of them, couldn't do much with it at all. Anyway, let's take a look at part C. Part C says, show the area of the plate is this. So how do we find the area? Hang on, I'm going to get rid of this stuff. The area of the plate. Because I think I got too much going on here. Hang on, let me see if I can get rid of this. All right, let's take a look at the area of the plate. All right. Now, we still do need this line here. We're going to go here. We're going to go here. We're going to go here. I can't remember if I need this or not. We're going to put this here. And we know that this is 2/3 pi, right? 2/3 pi, right? All right. So here's the trick about this one. We need to find the area of the plate. So what do we got to do? Remember, what did this whole thing start out to be? This whole thing started out to be a circle, yes?
Yeah.
Now, the thing is, it's going to keep on going. Okay? This thing started out to be a circle. So what if I found the area of the whole circle? Could I do that? Actually, I don't even think I need these lines. How do you find the area of a circle?
Use the formula pi r squared.
We do know that this has got a radius of 4. They told us that, right? So the area of the whole circle would be pi r squared, which is going to be what? What's our radius?
4.
So it's going to be 16 pi. Yeah?
Yeah.
All right. Now, what do we got to do? Actually, I don't think I needed this line, no.
What with the little, not little sections, but like, you know, like the areas that got cut or that got removed, would that be considered a sector?
Well, not a sector, but what is it?
Oh, an arc, right? Or not? What's it called? I forgot the word.
Well, what's this right here? What is this part right here? It's half a circle, right?
Yeah.
So we could take that away, yes?
Mm-hmm.
However, that's not going to account for this part up here. Do you agree?
Yeah.
So the question is, how can we figure out what that part up there is? Let's start with this. We have the whole thing is this, right?
Mm-hmm.
What's the two semicircles? What's the radius of the semicircle?
Is 2, right?
Right. So, and they're both semicircles, so really we can just figure out what's the area of a whole circle, and that would give us that whole thing, right?
Yeah.
So what's pi r squared going to be?
It'll be 4 pi, right? That'll be the area?
That'll be the area of what? The whole circle?
No, the semicircle.
So if I do 1/2 pi r squared, this is going to be 4, but then this is going to be times 1/2, so it'll be 2, right?
Yeah.
But there are 2 half circles, right?
Mm-hmm.
So if I just forget about this 1/2 and think of the 2 half circles as being one circle with both the same radius of 2, then it would be pi r squared, or what?
4 pi.
4 pi. Okay? Now, we got to take that away. 16 pi is the whole circle, and then we got to take away 4 pi. You with me on that?
Yeah, I get that.
That gives us 12 pi. All right, now we've got to take away this sliver up here and this sliver up down here, because they're gone too. Yeah? Does that make sense?
Wait, what's gone again?
Remember, this is a circle, right?
Mm-hmm.
So do you see this green dotted line?
Yeah.
That used to be there when it was a circle. Is it there now?
No.
So we got to figure out a way to take it away.
Okay.
See, what's happened is that, so we found the area of the whole circle, right?
Yeah.
And we've just taken away this half circle and this half circle. But the problem is, this part up here is still part of the whole circle. We've got to find a way to take it away. Does that make sense?
Yeah.
All right. So how are we going to get to that? We're going to call these like little segments. So let's go back and look at our lines. If this is a sector, yeah?
Yeah.
Then this piece up here would be part of that whole sector, right?
Yeah.
All right, now, what if I found the area of this sector How do I find the area of a sector?
It's 1/2 r squared theta, right?
Yep. Okay. Now, we already know what this angle is. Remember, we figured it out. What's this angle?
1/3 pi.
Yep. Okay. So 1/2 times pi over 3. And then we also know, what's this line? This line is 4, right?
Yeah.
So we know the radius, so we can square it, right?
Yeah.
So now this whole sector, now keep in mind, this whole sector is all this stuff. All of it. Hang on, let me go black again. This whole sector is all of this. Now, we just found out this whole sector, but we've got to take away the triangle. If I take away this triangle, well then the only thing that's going to be left is this sliver up here. Does that make sense?
Well, so like what you're thinking is that you're gonna find the area of the sector,
We're going to
and then
find,
subtract it.
and we're going to take away this triangle. What will be left over then?
It'll just be that little part, right?
It'll be this part right here, right?
Yeah.
Now remember, that's the only part we have left to take away. Now there's 2 of those little parts, yes? But whatever we find the first one, we just got to double it and then take it away. Does that make sense?
Yeah.
So first, we have the area of the sector. What's the area of the sector? What's 1/2 of 16?
8.
And so now that's going to be 8 pi over 3, right?
Mm-hmm.
All right, that's the area of this whole sector. How do I find the area of a triangle?
It's 1/2 times base times height.
Exactly. Now keep in mind, I know that this is 4, and I know this is 2, and this is 2. What's the base?
4.
4. Now, can I use Pythagorean theorem and figure out the height?
Yeah.
So we'll go like this. We'll say this is A. So that's going to be 2 squared. That's going to be this length right here. And then plus B squared, that's the height, we don't know what that is going to equal what? 4 squared. Yeah?
Yeah.
So then what am I going to do?
You square the. Yeah.
So what's 16 minus 4?
12.
12. And I square root it, what do I get?
Yeah. You get 2 with the square root of 3.
2 square root of 3. Yes?
Mm-hmm.
All right, now, what I've got to do is, well, take that away, right?
Yeah.
So what's 8 pi over 3 minus 2 square root of 3? Oh, wait a minute. So let's do this again. So let's go back up. What's the area of the whole circle?
16 pi.
And then what's the area of the 2 half circles that we took away?
4 pi.
All right. So now we have 12 pi after we take away the half circles, right?
Mm-hmm.
Now this right here is one of those aqua segments. I'm going to take away 2 of them. You with me on that?
Yeah.
So now all we got to do is kind of distribute here. This is still going to be 12 pi. This is going to be negative 16 pi over 3. This is going to be, what's negative 2 times this? Plus 4 square root of 3. Yeah?
Yeah.
So then what's 12 pi minus 16 pi over 3?
It gave me. Oh, wait. I forgot to put the 12 pi.
Yeah, don't do the 4 square root of 3. Tell me what 12 pi minus 16 pi over 3 is.
I got 20 thirds pi.
20 thirds pi. Okay, that's this, right?
Mm-hmm.
And then plus wait a minute, did we do this right? Yeah. Yeah. So then this is going to be plus 4 square root of 3, right?
Yeah.
Now, don't get me wrong. This is tough. If you were taking this on an exam, this right here is not that hard. And I can't remember because I don't have labeled what the points are. And this right here, the perimeter, not that hard. But this last part, that was a lot of work. And I don't know how many points it was worth, but you know what? Let's find out. I think it's on here. All right, so that first part, finding the angle, it's only worth 1 point. But again, it really shouldn't have been that hard, okay? finding the perimeter, that was only worth 2 points. And you can see what they did, the same thing. We took the arcs and we took the circumferences and the semicircles. Now this last part was worth 4 points. And I don't know. I mean, if I was taking this exam, I don't know that, you know, unless I knew like I was nailing it or whatever, I might go on and save this question for last if I still have time. That's a tough one. Anyway, you get the idea about what's going on here?
It's just like...
If you get a situation where there are not right triangles, try to create them. Find a way to make them. But that was a tough one. Take a look at this one. What do they want to know? We got a diagram. It's got a triangle. We know it's a right triangle. We also know that this angle is 1/5 pi radians. Yeah. We also know that AB is 5. Yeah. The arc BC. Now notice how this is a arc BC. Is part of a circle with center A. See, this is a center point. And I'm probably going to label it that to remind myself, because this is what I was talking about. Do you notice how this is a circle, a center point of a circle, but it doesn't look like it? And then it says center A meets OA at C, so that means they meet, right? Okay. And then CD is part of the circle O. All right, now again, that means this is also the center of a circle. I've got center O and I've got center A. And so then it says that the arc CD is part of the circle. Okay, that makes sense. And the area of the shaded region. Okay, find the area of the shaded region. All right. In this case, most of the information from the words is actually in the picture. However, if you don't read it carefully, it's really easy to get lost in the fact that this is a center point and that this is a center point. So now what do we got to do? Just big picture, what do we got to do? If we want to find the area of this gray part, what are we going to do? How do I find the area of the shaded?
You would find the area of the triangle, and then you subtract the area of the 2 sectors.
Exactly. What we're going to do is we're going to find the area of the triangle, and then we're going to subtract sector OCD, and we're going to subtract sector ACB. So the first thing we have to do then is find, well, we could do whatever we want, but I would suggest we find the area of the triangle. How do I find the area of a triangle?
Half base times height.
What do we know already?
The height.
How can I find the base?
We can use one of the trig ratios.
Exactly. Which one? Now take a look. This is my angle. It's the only angle. Well, I tell you what. Is it the only angle I know? I know this is 90, right?
Yeah.
Could I figure out this one up here if I wanted to?
Yeah, you could.
Because, right? But this is the angle I know right now. Are you with me on that?
Yeah.
All right, so if we're going to use this angle, then 5 is what side?
The 5 would be yeah, opposite.
Okay, now, what do I need to know?
You need to know the adjacent side.
So I need to know the adjacent side. So which of the trig ratios uses adjacent and opposite?
The the wait wait hold on.
So katoa, so ka.
Oh, 10.
All right, so let's try it. Tangent, and we know the angle. I'm going to say pi over 5. Now keep in mind, we're in radians, right? So your calculator has to be set for radians, is equal to the opposite, which is 5, over the adjacent, which is OB. Now what do I do?
You have to try and separate the two.
Well, I need to get OB by itself, right?
Yeah.
So what I'm going to do, basically, is multiply both sides by OB. So then it's going to be OB times tan. And then what am I going to do?
You'll do 5 divided by 10.
Yeah. At the end of the day, I'm going to end up with 5 divided by tan pi over 5. Does that make sense?
Yeah.
What is it going to be?
I got 6.8819.
6 point. Say it one more time.
88 and 19.
All right. Now, if that's OB, Mitchell, did you try it? Did you get the same thing?
Yeah, I did get the same thing.
All right, awesome. All right, now keep in mind, we're in the middle of a problem, so we're not rounding. I mean, you want to at least go, like, you know how we normally round three significant figures? I would always put a couple extra like he's done here, okay? All right, so now what? How do I find the area of my triangle? My area of my triangle is going to be 1/2 times the base, which is, what, 6.8 something? Times 5. What do we get?
17.204.
All right, so
More numbers, but yeah.
17.204. I got 77 after that. Is that right?
Yeah, same.
All right. And again, like I said, don't be stingy when you're in the middle of a problem. And because keep in mind, what's going to happen is we're going to take this and then we're going to subtract. We have more stuff we got to do, right? All right, so now, how do you find the area of a sector?
Is it half r squared times theta?
It is half. So we'll do OCD. OCD, 1/2 times the angle, which is going to be pi over 5, times the radius squared. How can we figure that out?
can probably try and make another right angle or another right angle triangle, but I don't think that worked.
Can I find, well, I know this length, right? Over here.
Yeah.
If this is 5 over here, if this is 5, what does this have to be?
Oh, that also has to be 5
Why?
because that's the radius.
Exactly. And do you see where remembering that this is the center of a circle comes in handy? Because if that's true, these two lines have to be a radius, right?
Yeah.
All right. So if I knew this entire length, I could take away 5 from it, right?
Mhm.
How can I do that?
Well, I thought you could use I think you could use Pythagoras theorem, but
You
you have a lot
could,
of
but I wouldn't suggest it. I could, but notice how I'm already using this rounded number?
yeah.
I'd rather use the trig and then use the 5. Does that make sense?
Yeah.
All right, so what side is this we want to do? What's AO?
AO is a hypotenuse.
All right, so, and I know the opposite, right?
Mhm.
So how am I going to figure this out? Sine of what?
Sine.
Pi over 2 is going to equal what? Opposite over what?
Opposite over hypotenuse.
Well, in this case, and that's OA, right?
Mhm.
So just like we did before, I'm going to multiply both sides by OA and then divide both sides by sine pi over 2. This is going to end up being OA is equal to 5 over what do you get with that?
I got 5.
You got 5? The whole length is 5?
Yeah, I got the same thing.
Hang on 1 second. 5 divided by sine. Oh, wait a minute. I've got written pi over 2. What's it really supposed to be?
1/5 pi. I was gonna ask you about that.
Yeah, I don't know what I'm thinking. This is supposed to be a 5. I copied it wrong. Let's try that again. Make it pi over 5.
I got 8.5065.
All right. Now, just take away 5 from it. What's left over? This is going to be 3.5065, right? Yay or nay?
Yay.
All right, so now take this and put it in there. And that's going to be the area of the sector OCD. What's that going to be?
I got 3.8627.
3.8627. All right. Now, how do we find this area? Now, again, we already know the radius. The radius is 5. How do we find this angle? How many degrees are in a circle?
360.
Yeah, how many degrees are in a triangle?
180.
How many radians are in a triangle?
Pi? Just pi?
Just pi, right? So, how much have I used up? I used up pi over 2, right?
Do you mean pi over 5?
Well, I'm talking about this corner over here, right?
Oh, right. Okay, so sorry.
Right? But then you're right. I also used up pi over 5, right? So what's pi minus pi over 2 minus pi over 5?
Three tenths pi.
So I'm going to say 3 pi over 10. Yeah? And see, this is going to be easier. We now have ACB, I'm going to say. ACB, that's going to be 1/2 times the angle, which is 3 pi over 10, times the radius, which is going to be 5 squared, which is going to be 25, right? What do you get when you do that?
I got 15 over 4 pi.
Can you make it a decimal for me?
11.7809.
Oops, hang on. 792, something like that. 79, yeah. Okay, I'm with you on that. All right, so now, remember our original thing. We found the area of the triangle. That's this. We're going to take away these two. So it's going to be 17.20477 minus 3.8627 minus 11.780792. What do you get?
I got 1.56109.
1.56, and we'll just round 3 significant figures. All right, does that make sense? All right, now this is actually a question, and it was worth 8 points. And I will tell you, one of the reasons I selected this one is because a lot of times in these problems, they walk you down a road. Find this. That's part A. Then find this. That's part B. Then find C. Find this. That's part C. And then they say show this. That's part D. And then they say find the gray shaded area. In this case, you really have to do all of it. Now it's worth 8 points. So think about it. This triangle area was probably worth 2 points by itself. The area of the sector was probably worth 2 points. The area of the other sector was probably worth 2 points. And then your process of subtracting them was probably, like doing this was probably a method point. And then getting the right answer is probably the 8th point. Now, in this case, there's a lot to do here, but none of this is crazy hard. Do you agree?
Yeah.
You got to know the formulas, and you got to know how to use them. And here's the key, and this is where people get messed up a lot. You got to be able to use trig to find angles and to be able to find lengths of sides. All right. It's 4 o'clock, and I'm only supposed to do this new content for an hour. I can take any questions about anything else you might want.
Mr. Cross, I wasn't here today. I really wanted to. What are the permutation stuff like the worksheet?
Yeah.
you gave Black and I tried doing them last night, and I tried looking up some videos. I'm really confused.
Yeah, don't worry. I bet you are. So here's my plan. Hang on, let me see if I can find it. What is this? Permutations. Here. Oh, I don't think I want to do this.
Yeah, that's me.
Hang on one second. Let's go back. But I'm going to open it with. All right. Okay. So here's the trick. It feeds off of itself. Do you understand what factorial is?
Kind of.
It just
So,
means you multiply every number below you. 4 factorial means 4 times 3 times 2 times 1. 3 factorial means 3 times 2 times 1. Okay?
Yes.
Now, the thing is, you don't really got to know why we're doing it, but you do need to know what factorial means. Okay? Now, if you're ever going to arrange unique things, and you're going to arrange all of them, then all you got to do is that number of things factorial. How many things do I got?
You're talking about the first one?
Yeah, A.
5. You have 5 letters.
5 letters, they're all unique. It's going to be 5 factorial.
Mm-hmm.
Okay?
Right.
Now, women, children, people are always unique. Okay? In this case, you know how it says boys and girls? If we're arranging all of them, then I don't care if they're boys or girls. They're just people. They're all unique. How many unique things do I have?
6.
So that'll be 6 factorial. And again, keep in mind, that itself isn't the answer. Take your calculator. You got your calculator?
Yes, sir.
Do you see where the factorial button is? It's near the middle of all the letters and stuff. Like if you look at like above the 9 and go up a couple buttons, do you see yellow where it says X with an exclamation point?
Yes, I do.
So if you do, for example, for the boys and girls, if you do 6 factorial, push 6, and then alpha, and then that explanation point. Do you see how it does that? What's the answer going to be?
Uh, 720.
Yeah, exactly. Okay? So your calculator is going to do the 5 times 4 times 3 times 2 times 1. You just need to know where that button is. Okay?
Cool. Okay.
Scenario number 2. What if some of the things repeat? What if some of the things are not unique? In this case, letters and words can be duplicated. All right? For example, you see this T? And again, remember, we're talking about permutations. We're talking about the ways we can arrange things. I could rearrange these letters in so many different ways. Yes?
Yes.
However, if I take this T and put it over here, and I take this other T and put it over here, do you see how it still spells table?
Or do you mean tablet?
Oh, yeah, tablet. Yeah. Do you see how it still spells tablet?
Yes.
What happens is when we have duplications, it causes us to have fewer permutations available. Okay?
Okay.
Because when they're duplications, well, then we reduce the number of arrangements because if I switch these two, it doesn't really change anything. It still spells tablet. Okay? So how many things do I still have?
6.
And so that's going to be 6 factorial. But whenever I have a situation where there are duplicates, I divide by the number of duplicates. In this case, I've got 2 T's. So that's 2 factorial. I would use the fraction button right below your option on the calculator.
Yeah.
Okay, so do 6 factorial divided by 2 factorial. Tell me what you get.
360.
Exactly. Okay? Now take a look at this one. Committee. How many letters are there altogether?
Or 9?
9. That's how many I'm arranging. However, some of them are duplicates. How many duplicates do I have? How many M's?
You have 2 M's, 2 T's, and 2 E's.
So it's not that I count up all the duplicates and I say, oh, 1, 2, 3, 4, 5, 6. It's I've got 2 M's. That's 2 factorial. I got 2 T's. That's another 2 factorial. And I got 2 E's. That's another 2 factorial. What's that going to equal?
I got 45,360. Is that right?
Yep.
You multiply the factorial, the 2 factorial, 2 factorial, 2 factorial together, right?
Exactly. So like I said, on my calculator, I'm using that fraction button and I'm making it look just exactly like this. Okay?
Okay, because when I did that at first, it gave me syntax error, then I put multiplication.
Oh, yeah, right. And I forgot about that today when we talked about it. Yeah, and see, that's the thing. I mean, if this is one situation where it doesn't look, doesn't work exactly the way you write it, but yeah, it's got to be multiplication between them. Yeah?
Gotcha.
So
Okay.
in here, how many numbers do I have? 1, 2, 3, 4, 5, 6. 6 factorial. How many are identical?
5 of them.
What's that going to be?
6.
Okay? So, anytime that there are things that are duplicates, exact copies, then you divide by that number to take into account. Okay? Now.
Okay. Wait. Sorry, real quick. What about the second one? So would that be
Well, how many
6
numbers do we have altogether?
6,
6 factorial. Now, how many duplicate ones do I have?
3,
How many duplicate 7s do I have?
3.
Notice it's not the 7, it's just the how many duplicates.
Wait. How many?
I don't care what number it is. I just want to know how many of them there are.
There are 3.
Right. What's that equal? What'd you get?
20.
Okay. You see how this works?
Okay. I was confused because I saw a video and I thought I had to
Well,
do.
don't worry, because there's more. It does get more confusing. But these other ones are going to work the same way. Okay? All right, now take a look down here. What happens is then they'll throw in restrictions. And what happens when you have restrictions, you've got to take into them consideration first. So, for example, it says, how many ways can 6 men be arranged in a line so the oldest man is on an end? Well, I'm going to say, now keep in remember, whenever I say we talk about people, they're all unique. So you could rename them A, B, C, D, E, or I just go like this. The oldest man, he's going to be M6. Are you with me? Now,
Okay.
I put him on the end. Are you with me?
So far.
There's only one way I can put the oldest guy on this end. Yes?
Right.
All right.
Okay.
Now, is there any requirement for anything else? Say no.
No.
How many men do I have left?
5.
And are they all unique?
They should be.
You are. Okay? People are always unique. So we don't have to worry about duplications when you're talking about people. Okay? So now the other situation is the oldest guy could be on the other end. Yes? Now there's one way for that to happen if the oldest guy stands on the end. But now all these could be rearranged. In how many ways?
5 again.
5 factorial. Okay?
Okay.
So Think of it like this. I put the oldest guy on this end, and then I rearrange them all the rest of the men. Blah, 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 blah. What's 5 factorial?
120.
This guy isn't moving. He's always here. You see what I'm talking about? But all the other 5 guys are all getting rearranged into 120 different ways. Okay?
Oh, okay.
All right?
Okay.
Now, here, I put the old guy at the end. And then the other 5 guys, they all get rearranged 120 different ways.
Okay.
Now, how many ways can the oldest man be arranged so he's either on either end? Well, 120 if they're on this end and 120 on this end. So altogether, there's 240 ways for us to arrange those guys with the old man on the end.
Okay.
So take a look at number 2. How many ways can 6 men be arranged so the 2 oldest men are on the left? All right, now we're talking about here, right? So I'm going to say M6 is the oldest and M5 is the next oldest. Are you with me on that?
Yes.
All right, now the thing is though, how many different ways can these 2 guys be arranged?
Only one way.
How many things do I have?
6.
2. I'm not only talking about these 2 guys. How many guys do I have?
You have 2.
And they're unique. How many ways can they be arranged?
1 or 2.
Now, what is 2 factorial?
2.
2 times 1, right? Now think about it. The oldest guy could be here, or they could switch places. Does that make sense?
Right.
So
Okay,
do
now
you
I
see
see
how
it.
there's 2 possible arrangements for the 2 oldest guys?
Yes.
There are only 2. Now, it doesn't make a difference. Logically, I can tell there's only 2. But because I have 2 unique guys and I'm arranging them 2 factorial ways, it still ends up being 2. Yes?
Yes.
Now, that's how many ways I deal with this part. Now, forget about that part. How many guys are left over?
Excuse me. 4.
And do I care much about them?
Not really.
Better yet, I care about all of them, but there's no restrictions, right?
Yes.
So they can be arranged 4 factorial ways.
That's 24.
So now I take, so again, imagine it. 24 ways with the oldest guy here and the next oldest guy next to him, right?
Mm-hmm.
But then there'll be another 24 ways when they switch places. What's 2 factorial times 4 factorial?
48.
Does that make sense? There's 24 ways if they line up exactly the way I've written them. The oldest guy here and the next oldest guy here, and then the other guys get rearranged to their 24 ways. Okay? But these 2 guys are always standing in the front. But if they switch places, well, now I start all over again. And there's another 4 factorial ways. So all I do is multiply the ways these 2 guys can be arranged times the way these guys can be arranged. 2 factorial times 4 factorial is going to be 48.
Okay, that makes sense. Okay.
So think about this. Number 3. How many ways can the 6 men be arranged so that the shortest man is not on the end? So in this case, we're not going to focus on the shortest man. On the end, I need not to have the shortest man. How many men are not the shortest?
5?
5. There are 5 men. Yes? 5
Yes.
men that could go here, right?
Mm-hmm.
So consequently, there are 5 ways that I can fill that position. Does that make sense? There are 5
Right.
different men that are allowed to stand there. I can fill that 5 different ways with 5 different men.
Mm-hmm.
Now, let's go to the other end. How many men are still not the shortest after I put one of them on the front?
5.
Now we have 6 men altogether, right?
Oh, right. I thought when it said end, I thought it meant either end.
That's what I'm talking about. So I put one guy here. How many men are left?
Wait, 5?
5. But one of them is the shortest. How many can stand on the other end?
6 or
How many men are all together? How many men do I have?
oh, because one's there, right?
I've got one man standing over here. Okay, now I don't know who he is. All I know is he's not the shortest. He's one of these 5 guys. Yes?
Yes.
Now, the shortest guy is definitely here in the middle.
Right.
So then, if I've got one guy here and the shortest guy is somewhere in the middle, how many guys are left?
4.
4. Does that make sense?
Yes.
Now, I'm only going to put one guy here, but how many choices do I have?
4.
Because there's 4 men to choose from. Does that make sense?
So far, yes.
Okay. So, I've taken the 5, I've put one of the 5 not shortest men on the front, and then I've taken one of the 4 leftover not shortest men on the back. Now, how many men are left for the middle? I've got one man in the front and one man in the back. I don't know exactly who it is, but I know I've got one man in the front and one man in the back. How many are left?
4.
And that includes the shortest man, right?
Yes.
So then these spaces are going to be arranged in 4 factorial ways. How can I arrange this first space? 5 ways. How can I arrange these middle 4 spaces? 4 factorial ways. How can I arrange this last space? There are 4 different ways I can make that happen. What's 5 times 4 factorial times 4?
480.
And this is what I'm talking about. They can get a little confusing. Whenever they talk about requirements, then you always go back and focus on the requirements first. Does that make sense?
Okay. Yes.
So take a look at the 4th one. I'm making a 5-digit number. Okay? That means I've got 1, 2, 3, 4, 5 numbers, and I'm going to use each one once. Okay? If there was no restrictions, how many different numbers can I make if I use each one of these once? How many different ways can these 5 numbers be arranged?
120.
Because that's what?
5 factorial.
Okay. Whoops, what happened there? Okay? Now, let's put some requirements on there. What if the number is odd? 1, 2, 3, 4, 5. It's a 5-digit number, right? What digit makes it odd?
3 and 5.
Well, but where do I put it? What digit do I look at to determine if a number is odd? Here.
I'm sorry.
How do you know if that number is odd?
If you can't divide it by 2?
No. What digit do you look at?
The last one.
Tell me about
Right.
this one. Is that number odd?
That's even.
How do you know?
Because you can divide it by 2.
Because the last digit is even.
Wait.
Does that make sense?
Sorry, yes.
Okay? Now, that means that the last digit has to be which numbers?
They have to be the odd.
Which
That's
ones
okay.
are they? What do I have? What are available to me?
3 and 5.
So, I could put a 3 or a 5 here, yes? So that means how many choices do I have?
You would have 2.
I've got 2 choices for this last spot, yes?
Yes.
Now, the rest of the numbers can be put in any other way I want, right?
Yes.
And they're all unique. So that's going to be arranged in 4 factorial ways.
Yes.
What's 4 factorial times 2?
48.
That's how many ways I can make an odd number out of this. Okay?
Right.
All right. Now, what about this? What if the number is even?
Okay, so if it's even, you have 3 numbers that can be even, so you would have 3 choices.
3 choices, right?
3 choices at the end, so 2. 4.
Now keep in mind, just because I'm putting the number 3 there, it doesn't mean the number 3 goes there. It means I have 3 choices to put there, right?
Yes.
And then how many ways can I arrange the other numbers?
4 factorial.
Exactly.
4 different ways represented by 4 factorial.
What's 4 factorial? 3 times 3.
72.
All right. Now, this one's more difficult because they have 2 requirements. What are the requirements?
It has to be odd and less than 4,000.
40,000, right? Okay, so let's talk about this. 1, 2, 3, 4, 5. If it's odd, we already know that either a 3 or a 5 have to be at the end. Yes?
Yes.
But now I've got this new criteria for it being less than 40,000. So tell me about what happens. What numbers can I use in the first digit to make it less than 40,000?
2 and 3.
That's true. Now the problem we run into is, do you notice how the 3 could be at the front or at the back?
Oh, yeah.
All right, so here's what I'm going to do. What I'm going to do is I'm going to figure out the number of ways that I can have an odd number if the 2 goes first.
Gotcha. Okay.
So I'm saying that first number is a 2. It's not going to change. That first number is a 2. As a matter of fact, I should go like this. Hang on. I'm going to say it like this. The first number is a 2, and there's only one way for that to happen. I'm going to put the 2 there. Okay?
Okay.
All right. Now, what number could go at the end?
In this.
If it's odd, it could still be a what?
3 and a 5.
So it could be a 3 or a 5. How many ways can I make that happen? 2 ways. Yes? All right. Now, tell me about the numbers in the middle. How many are left?
3 spots.
And so that means it's going to be 3 factorial. Yes?
Yes.
All right. Now, the thing is, though, this is only going to give me the numbers in the 20,000s. Because what's the first number?
2.
So now I got to go like this and do it again. 3, 4, 5. And now what number do I put in the front?
3.
Now it's going to give me the number in the 30,000s. Does that make sense? Now that I've put a 3 in the front, and I'm only allowed to use each number once, what could possibly go at the back if it has to be odd?
5.
Are you with me? Now, there's only one way for me to put a 3 here, and there's only one way for me to put a 5 there. These can be arranged in how many ways?
3 factorial.
So what's going to happen is I'm going to do 3 factorial. Whoops, that didn't work. I'm going to do 3 factorial times 2. That's this up here. And then, okay, well here, maybe this is even better yet. Let's do this again. Let me get rid of it. All right. What's this going to equal?
12.
What's this going to equal?
6.
Altogether, how many ways would I be happy with?
18 ways.
Okay?
Yes.
All right. So, let's take a look here. And what's going to happen is I didn't get through all of this today.
Okay.
And so what I'm going to do is I am going to post a video, but I do want to just talk to you about this beginning part. And then, like I said, look for me to post another video. You with me?
Yes, sir.
Okay, so here, look at your calculator. Do you see like above the delete button or below the delete button where it says NPR?
Yes.
That's what this is talking about. Now, in all the problems we did before, we arranged all of them. Okay?
Okay.
Say, for example, and so this is the number of items. This is how many in the arrangement. Okay? Now, what if I had 5 things and I was arranging all of them? What would you get? Push 5, then shift, and then NPR, and then 5. What do you get?
120.
You get 120, right? Now, do 5 factorial. What's 5 factorial equal to?
120, right? Yeah.
Okay. Now, again, I want you to think about it. When we did the factorial, we were arranging all of them. Yes?
Yes.
So what happens is most of the time when we use this NPR button, it's when we're going to arrange less than all of what we have. So, for example, I'm going to make a 3-digit number out of these numbers. Okay?
Okay.
How many numbers do I have to choose from?
7.
I'm going to arrange them in the groups of what?
3.
Because it's a 3-digit number, right? How many different ways could that happen?
210.
Okay? Now, similar problem. How many numbers do I have to choose from?
7.
How many am I arranging them in? 3. But what's different about this? What's different about B?
There are 2 3s.
Okay. Now, again, just like factorial, whenever you're arranging things, whether you're using the P or the factorial, whether you're arranging all of them or some of them, whenever there are duplicates, you have to take that into account. But you take into account the exact same way. I've got 1 pair of duplicates. There's 2 of them. So I would do this. 7p3 divided by 2 factorial.
I got 105.
You got what?
105.
That sounds... I don't remember what that is.
Did I do it right?
I'm sure that's fine. I'm sure that's right.
7p3 over 2 factorial.
7p3 divided by 2? Okay.
2 factorial, yes.
Right? Okay.
Yeah.
So here, if I was doing this for number 2, how many cards do I have to choose from?
52 cards.
But I'm only arranging them in groups of 5. So that would be 52p5.
That's a big number.
Yeah, okay. Now, Now, and I will tell you, this is not worded very well. So let's change it to say hearts are only in the first two.
Okay.
Now, I'm still drawing 5 cards, but the first 2 have to be hearts. Does that make sense? So we're going to start this. How many hearts? 1, 2, 3, 4, 5. In a deck of cards, how many hearts are there?
52.
Well, 52 cards in the deck, but how many hearts are there?
Oh, hearts. I thought you said cards.
Yeah.
There were
13, exactly, right? So I have 13 hearts to choose from, and I'm going to arrange them in these 2 places. That's 13 P2. That gives me 2 hearts. Yes? Now,
Okay, yes.
I'm not using hearts anymore. So what's left over? What's 52 minus 13?
39.
So now I've got 39 cards to choose from. I don't really care willy-nilly who goes where. I'm going to arrange them in groups of what?
3?
3. Because remember, I've already filled in these two spaces. They are hearts. These last 3, they could be clubs, spades, diamonds, I don't care.
All right.
So to find the way that this can happen is I multiply those 2 together.
I got 855. Wait.
8,554,104.
Yeah, million. That's confusing. Yeah.
Okay? So what I want you to do is see if you can go back and work on some of these ones that we skipped and see if you can make any sense out of these few other ones here, okay? But like I said, don't worry, because some of you are not going to know, like boys together or separated. But what I'll probably do is when I go to make the video, I'll probably start with this I don't know what I'm doing. I may make it over the whole paper. I don't know. We'll see. But I'm definitely going to make sure that I focus on this back part so it'll get explained to you.
Okay, awesome.
All right? Anything else before I let you guys go?
Oh, Mr. Cross, are you gonna stay after school Monday?
Yeah.
Not Monday, next Monday?
Yeah, Monday.
Or,
I'll be here.
yeah, because I want to go over some probability. I feel like I'm kind of iffy on some of the stuff still.
Yeah, no worries. We can do that.
All right, yeah. Thank you.
All right?
I just want to say thanks for the help. I really appreciate it.
No problem, man. Have a good one. Look for the video. I'll post it. It probably won't be tonight. It may be tomorrow.
Okay.
All right?
Have a good weekend.
You too.
Thank you, Mr. Cross.
Have a good one now.